First talk after lunch. I wonder how many of you are, like energized versus sleeping. All right, let's do this. So I want to start with a story. Our story starts a couple years ago. Back then, I was part of a team working on a small internal application in a previous company. One day, we got paged by our infrastructure team because our worker servers were at 100% CPU usage and had been that way for a couple hours. Something was wrong. This was related to our workers, so of course the first thing we do is we open our Sidekick dashboard and we saw this. Yeah, that's right. Over 800,000 jobs in queue. This was a small internal app, so this was not expected at all. We fixed the issue. I don't want to get into the details here, but we wanted to figure out why this happened so this wouldn't happen again. So someone in the team asked the natural question, hey, can we check our logs? And when they said that, the first thing that popped into my mind was something like this. So we do have logs, but they're piles of raw texts that are hard to use and to find anything in. It was painful and far from the best experience. The second thing that popped into my mind was this tweet I read a couple months prior and that came back to haunt me. So yeah, our logs are trash. This hits too close to home. Now, that kept me thinking, why trash? Why can't we use them to get actionable insights? That's why they're trash, because we can't do that. So what Charity meant was that our logs were not data. They're just piles of raw text with no value. But that got me thinking, what if they were? What if instead of piles of unstructured texts, we could treat our logs like data and use them to get valuable and actionable insights? Hi, my name is Youssef, and I want to talk to you about turning logs into data. I am a senior engineer at Workato, where we create a product for companies to automate their business processes without writing any code. Like all of you, I love writing Ruby. I've been coding in Ruby almost my entire professional career, and I especially enjoy working on developer tools, because I believe that coding should never be a chore, and that making developers more productive is just a joy to work on, and it's actually my second favorite hobby. I say second because my first passion is photography. I rarely go out without my camera, and if I'm lucky, I get back with some shots that I'm happy with, such as these. So speaking of logs, our agenda for today, we're going to start by looking at the default Rails logs, which questions they can help us answer and which ones they can't. In the second part, we're going to introduce more structure into them and shape them into data. And finally, we're going to see a showcase of the kind of insights we're going to get from them. So let's start by looking at the default Rails logs. And to get logs, we have to first run some code. So there's a basic action that everyone should be familiar with. So just an update user update action. You take a user, you find them, you update, and then you redirect to an action. So the default Rails logs look something like this in a very simplified case. So we have 5 lines output total, and we do. Let's see if we can get this. We start by, the request starts, and then we output a line. Then we start processing the request, and we output a second line here. And then we also output the parameters, which is like the user, the country, the locale, everything that is in your application. Then we redirect, so we also output something here. And then at the end, we have a little summary of the request. So these are the logs we all have by default. So what kind of questions we can ask these logs? So we can ask, how many patch requests do we process per day? We can ask, which controllers are our busiest? Or what's our rate of 404 responses? But are these really the questions we want to ask? As one French philosopher once wrote, judge a man by his questions rather than by his answers. So I went to French school, so by law I have to quote Voltaire at least once a month, or they come for me. But in all seriousness, I find that thinking about questions is often more valuable than getting the answers. So what are the questions we want to ask? So we want to be able to ask, which requests did this specific user perform? Or why did we suddenly enqueue a large amount of jobs? Or how many users are using this legacy API endpoint that we've been wanting to retire for a while? And what do they all have in common? Or another question that's a bit more complex is this feature flag affecting database performance on some revision of our code in US East 1? So notice that this question is about correlating data from completely different parts of our stack. So the application, the database, Git, and infrastructure. So why can't we answer these questions with our logs today? My theory is that there's 4 main issues with these logs. So first, they're multi-line. So it's okay when we see things like this. It's relatively okay because when we process a single request. But then when we aggregate the logs from multiple servers, which we can have hundreds of, they all become intertwined and it gets impossible to actually make sense of them. Second, they're not structured. They're made for human eyes, but it's hard to analyze programmatically and actually get patterns from them. Third, they're missing the main data, so there's no concept of user or revision or AWS zone. There's nothing here. So there's nothing we can query against to analyze their data. And finally, they're uncorrelated between systems. So meaning each systems and each app's logs only refer to that single system. And we can't correlate, for example, the logs that are output from a worker and from web. So can we fix this? At least what we have with these 4 issues is that we have 4 problems, we can tackle them one by one. And that takes us to the second part of the talk, where we'll take all these 4 points and see how one by one we can fix them. So our first problem was that logs were multi-line. This is what we saw before, so I call them print-as-you-go logs. So as the request goes through the Rails stack, it outputs log lines for each step. So this gives us a kind of a story for the request lifecycle. It's telling us, oh, I started, and now I'm processing, and then I'm redirecting, and I'm finished. But that's not interesting to us. What we want is we want a summary of that request. We want to have all the information all at once. So what we do is we can consolidate these logs. And it's actually pretty easy when you're doing Ruby, so there's a gem for that. You can use lograge, which is the OG, or Rails semantic logger, which is more advanced. But both of these will give you something like this. So all the request goes through the stack, there's nothing output, and just before the request exits, it outputs one single line with exactly the information that we had before. So we have the methods, the path, format, everything that we had before, but consolidated on a single line at the end of the request. So we fixed the first part. Problem number 2, those logs are unstructured. When we have unstructured logs, we can structure them. So what we can do to enable structured logs is both the gems I mentioned before have a setting for formatting logs in a certain way. So here we're going to use the JSON formatter for lograge. And what it does is that instead of having this key value pair that we had before, we have a JSON document as an output. It's a bit hard to read here, so I just expand it, but it's still one single line that's output. And here we have, it's a key value pair is a JSON document, we all know that, in that has all the information from all the requests that just came through our stack. And we can even structure information inside, like this params here, where we have a nested JSON document, so we can actually have structure. So this is a key point. What we just did here is we turned logs into data. If you're going to remember one key point from this, that's it. Structured logging turns logs into data by outputting one single structured line at the end of each request. You can think of them as an event that the request produces, an event summary. So we can continue by tackling problem number 3. Logs are missing data. So what we can do is we can enrich our logs, because now they're structured, but they only contain generic information. They don't know anything about our app. So we can enrich them with domain information. I'm very thankful that the screen is big. So we can have, like, for example, information from the environment here. So we can pass the proc type, the revision, or the AWS region here. We can have the extra data from the request, like the request ID and the user agent. Or we can have anything that you can think about in your controller. So we can output the locale, we can output the current user information, and anything that is relevant to your specific application. And we get something like this at the end. It's truncated, but it's exactly what you expect. So we have all the information filled in the JSON document. We have the proc type, revision, locale. And I want to spend some time here with a couple of warnings. It's a bit too easy to shoot yourself in the foot doing this. So there's 2 points I want to address. The first one is performance. So only log information that is cheap to compute. So environment variables are okay. Objects you already have in memory are okay. But don't put extra database calls to enrich your logs, because that overhead there can be significant. And the second one, which is a bit more pernicious, is accidentally exposing private information. It's way too easy to accidentally log sensitive information to logs. And actually, if you didn't do anything to your Rails app by default, you're probably outputting sensitive data to your logs, because we're outputting the params object by default. And that can contain name, emails, birth dates, social security numbers, because you have the user update action, and there's a lot of stuff in there. So what you can do is, if you're really strict about that, don't output the params object. Or what you can do is that you can use, Axis4 has a feature called parameter filter, and it can be used to filter some sensitive data. For example, if you know that all your params are okay, but maybe name and email are not okay, you can have a blocking list there. And I want to end this section by just showing you one example of this going wrong in the wild. So 5 years ago, Facebook was caught storing user passwords in plain text. And this is not because they were storing the data itself in plain text in their database. They're too smart for that. But because they were logging them as part of their parameters. So yeah, be careful about this. And lastly, we want to check problem number 4, where the logs are uncorrelated between systems. So what we do, again, when you have uncorrelated logs, we can correlate. So correlation means linking logs between different systems. And as such, it's like we can, it all depends on your systems, so it's hard to give general advice here. But I want to show you 2 examples of correlating logs, just for inspiration. So the first example is in the context of distributed systems. Sometimes you have dozens of microservices calling each other just to answer one single HTTP request. I don't know why you would do that, but okay. So how do you track this? How do you track who calls whom and like which requests were done to answer this one request? So one way is to have the entry point service, maybe the gateway, generate a unique ID, which is usually called correlation ID, and then you pass it as an HTTP header to any subsequent request. So this is the header that we're passing, and then any system that gets this correlation ID will output it again in their logs. So that means that if you filter by your logs by correlation ID, you get to see all the requests that are in the chain. A second example is how to correlate jobs and web requests. So Sidekick has the concept of middlewares, where you can add metadata to jobs when they are enqueued. So what we can do is you can have this enqueued by request ID, UID that you add to the job request, to the job when it's enqueued automatically, so that whenever you have a job that's executed, it will output this request ID so you can trace exactly where the job came from. So to recap, we have consolidated our logs into one line per request. We structured them into JSON documents. We enriched them using the main data, and we correlated them between our systems. And that gives us something like the log line on the right there. So what now? This is the fun part of the talk. We're entering the third part of our agenda, where we'll see how we can analyze our logs in different ways. Logs are now data, so we can treat them as such. And what we do is we first ingest them into our data analysis platform of choice. There are many to choose from. I do want to give a special mention to BetterStack, who's sponsoring this conference. You can find them in the booth outside, and they'd be happy to talk to you about this. But for this presentation, I'm going to be using Kibana, which is based on Elasticsearch. Sorry, BetterStack. They're not paying me for this. I just like their product. So this allows us to go from this one log line to this. It's a document in a database. And from this nonsense to this. It's a queryable database of all our requests. So back to our questions. We wanted to ask, which requests did this specific user perform? Now we're going to see how we can do this in using this Kibana. So we're going to start from having all the logs, which is 24,000 here. And we are logging the user ID, so we can use this to filter the requests that come from that user ID. There you go, 20 hits. Not only that, but we can also select different fields that we're interested in. For example, we want to see which controller, which action, and what the duration of the requests. And now we have a nice table here where we see for each of the 20 requests that the user made exactly which data we wanted to see. So next, we wanted to ask, why did we suddenly enqueue a large amount of jobs? Again, we're going to start from all of our logs. And we're interested in jobs, so we're going to start by filtering the Sidekick logs only. And here we can visually see that this app doesn't have a lot of activity except here. So we're going to try to focus on those log lines there. We know roughly when they appeared. And then we're going to try to look how can we correlate all of these things. Remember, we added this enqueued by request ID to our logs before, to our Sidekick logs. So we can add it to the table. Then we can see if we can find anything that's weird. And here we see a lot of jobs that have the same request ID that enqueued them. That is fishy. But we have something. We have the request ID, so we can just look for it. Find it. Then we can see which controller Maintenance tasks controller, okay. Action, start daily cleanup. That sounds weird. So now we know exactly what happened and why we enqueued all these jobs. But we can do more. We can see who enqueued these jobs. And you can get the user email and user ID from there. And of course, it's super admin, so me. So yeah, from our logs, we were able now, because we had all the data there, to get actionable insights and know why this problem occurred and what we can do about it. We're going to continue. How many users are using this API endpoint, this legacy API endpoint, and what do they have in common? So now instead of seeing the logs in a list, we're going to visualize them. So we're going to first try to see how many users we have. So we want to count the unique users by the unique requests by user ID. And we got the number, 109. But that's for all our app. We want to see exactly who's hitting the legacy controller. So we can filter by the legacy things controller. And there you go. We have 7 users that are using this legacy controller. But we want to do more than that. Who are these users and what do they have in common so that we can actually retire this endpoint? So we do the same thing, but now instead of just a number, we're going to do a pie chart. So we're going to count, those are all of our requests. Same thing, so before we're going to filter by controller. And then we're going to slice the data by guesses. Let's see, maybe they all come from the same AWS region. No, they all come from all over. So maybe they're coming from, their requests are in a specific format. No, we have both HTML and JSON. Maybe they're using a specific language. Nope. Maybe, I don't know, user agent is the same. There we go. So we figure out that all our requests that are hitting the legacy controller are coming from our old mobile app. And we can't take the iPhones away from people, so we just have to retire them. And this is our last question. Remember, this is the one that went all across the stack. Is this feature flag affecting the database performance on revision something in US East 1? And what we did when we enriched our data, our log data, is that we kind of collapsed all of these places in our infrastructure into one single level. So this is now actually pretty easy to do. So it's going to be a bit faster. So you want to have a graph of the database runtime filtered by revision and AWS region. And we want to splice it by, is the feature flag enabled or not? There we go. We see that clearly, if you enable the feature flag, the database performance takes a hit. So, structured logs are awesome. By turning logs into data, we can use them in new ways. We can slice and dice the data to explore patterns, answering new questions without changing any code. These questions can range from the needle in a haystack kind of questions to long-term trends. You can almost think of them as technical business intelligence for developers. And I can guarantee that once you try this, you can't go back to tailing logs. So we're nearing the end of the presentation. So I wanted to mention just a couple final words about structured logging in a larger context. First is, this is not new. This practice has been around for years. Heroku has that in their guides. Stripe has a blog post from 2019 calling them canonical loglines, but it's just the same. And even a couple months ago, there was this blog post on Hacker News with like, wide events is what you need. Wide events is just this, structured logging. They call them wide events because their theory is that you should try to put all the data you can in them so the JSON documents get pretty big. And there's even this quote by DHH, stating that Shopify and 37 Signals have been using in-house structured login for a long time. So this is not new at all. It's not a very well-known feature outside of larger companies. So we are lagging behind. We, the Ruby and the Rails community, are lagging behind in the adoption of this practice. Other communities, like if you turn to the Java communities and the Golang communities, they have integrated this into their tooling a while ago, and it's almost a given for new projects. But in Rails projects, you still have to do some work to get this. And you only see that happen in mature projects. But let's fix this. Rails builders, if you're building anything, try this approach. Try structured loggings, use it, and spread the word about it. I guarantee you will not regret it. Gem maintainers, if you have a gem, consider adding an optional structured login option for your gem so that all your logs can be ingested in such systems. By the way, this applies to Rails too. The DHH quote I just gave you, it actually comes from an issue that was created late last year. There was a proposal to add structured login directly into Rails. I'm very happy about that. But we don't have to wait. In the meantime, we can all use structured login today and start asking our logs the questions we want to have answered instead of merely the ones we can. Thank you.